So initially, first we'll start why do we need exactly IP version 6. So what is the reason? Because already we have some IP version 4, and then why we need an IP version 6, and what are the advantages of IP version 6 we get when compared with IP version 4, and then finally we'll see how it looks. And then in the last of this video we'll be discussing the classification of addresses. Okay, so let's first see why do we need exact IP version 6. So now the main reason of using IP version 6 is the need of more addresses, the requirement for more addresses, because the internet size is growing with a very high speed. So initially, IP address, if you talk, there are two versions of IP address: the IP version 4, which we are still using it, and also we have some IP version 6. So now IP version 4, which was developed around 1980s, which was used when the internet was new, and we are still using IP version 4. It is 32-bit address written in decimal format. We know how it looks in a decimal format, and majorly it supports to the power of 32 addresses. To the power of 32 means it goes around 4.3 billion IP addresses. So it's a very big number, but still this big number was not enough to meet the growing network requirement. The number of people connecting to internet was growing at a very high speed, and the technology how it develops now, each and every user carries internet in their mobile phones. Even there are some cab services which also part of the network. Even there are some electronic devices like washing machine, refrigerators, ACs. So probably they are also been a part of the network. So there are many things growing as per technology. So as the growth of the network increases, so especially the main reason is internet. So everyone requires internet now. So the number of people connecting to internet was growing at very high speed. So as the number of people connecting to internet was growing, we also need to have a more number of IP addresses, because each and every user should have a unique registered IP address. That is what we call as public IP. So now, whatever the number I just discussed, 4.3 billion IP addresses were not enough to meet the growing network requirement. Okay, so that's the reason. So around in 1993, experts realized that there will be a one day where we can come with a shortage of IPs if the internet grows, something like this. So it was growing, it was almost doubling every year. So they was just thinking uh, of developing a solution which can overcome this problem. So they developed two solutions. The one solution we is IP version 6, which is not a full-fledged implementation still, but IP version 6, which was developed in 1999, around in June, they released a full-fledged IP version 6, a tested version of IP version 6, which is ready to be released in the market, means ready to implement. But still, they did not implement completely because of one more development called NAT. So before NAT, we discussed NAT in the previous sessions. If you remember, in the basic CCNA, using NAT, we can allow more than 60,000 private users can go to internet with only one registered public IP. So I can use a one registered public IP, and I can provide internet access to more than 60,000 users. So because of NAT, we are still surviving with IP version 4. So we are still using IP version 4 only because of NAT. NAT, in other words, you can say NAT is extending your IP version 4, or in other words, even we can say it is hiding your IP version 6. So maybe we are extending more than 10-12 years, expected by 2010, 2012, and maybe from you'll see some IPv6 implementations. So that's the reason whatever the networking devices coming into market, like if I talk about Windows operating systems like Windows Vista, starting from Windows Vista, it has been made mandatory that every networking device, it can be operating system, or it can be Cisco iOS, whatever the new iOS releases from Cisco, or it can be any other vendors. Even if you take an operating system, every networking device, they made mandatory that they should support IP version 6. So we have a default options present into it. So if you talk about Windows XP, there was no IPv6 option by default, but you can install the protocol, but still it supports. But from Windows Vista, you have a default IPv6 tab, like that. So this is small basic history on why exactly we need an IP version 6. So NAT is a temporary solution. We are still using it, and NAT is not a permanent solution. So they know that one day they need to mandatory implement IP version 6. But NAT was a solution which was extending your IP version 4. okay, and it is hiding your IP version 6. So now IPv6 is the major topic in our today's network, because slowly most of the service providers and many major companies, they started deploying IP version 6. Okay, so it has been it is really mandatory to know IP version 6. In today's network, you need to have a very good understanding on IP version 6, similar to IP version 4. Okay, so it also have some a lot of advantages. So now the next thing we'll see, what are the advantages we have in IP version 6. IP version 6, majorly it's a very large address space. Here I got some advantages. A very large address space, which means it supports 128-bit address, which means 2 to the power of 128. I can say around 3.4 into 10 to the power of 38. So it's a very big number. Each and every human can get an IP address. So they kept in mind, even if the internet grows more than double every year for the next 50 years, 50 plus years, we can still survive without any shortage of IPs. So it's a very big number. So probably we can, every human can get an IP address, I can say. Still we have more than half of the IPv6 addresses available. And also you don't need to translate them to public or private. You can directly use a registered public IP on your PC without translation. So you have end-to-end reachability. And also header format is a little bit simplified, and there's no broadcast concept in IPv6. We'll see this broadcast, this multicast, actually it uses multicast addresses for sending a packet to everyone. So no more broadcast is no more broadcast ID you'll find in IP version 6. And there is some new configuration method, stateless auto configuration, we'll see in the next coming classes. And then it also supports something called mobile IP, where you can connect to multiple networks without losing the connectivity, where we are shifting from one connection to another connection. And also you have something called IPsec security. So this is something, if you know about some security basic concepts, there is a feature called VPNs, and there is a protocol called IPsec, which is going to provide some encryption, provide some security to your traffic. So, but there is not default. You need to configure. But IPv6 supports inbuilt IPsec security features, and also you have some rich transition methods. Transition methods means translation methods from IPv4 to IPv6. We'll see in advance IPv6 topics in the later on sessions more in detail. And also we have some labs and all that. And IPv6 renumbering is also a little bit easier. And also you have the feature, you can, on a single interface, you can apply multiple interfaces, which means the same interface, you can have multiple IPv6 addresses. So we'll see these things more in detail when we come to the labs. So these are some of the basic advantages we can say we get in IP version 6. And the next part, we need to understand how it looks. Now IPv6 address looks something like this. Here I got a simple format of IPv6 address. In general, IPv6 written in hexadecimal format. Hexadecimal, you know, hexadecimal, just like we had decimal numbers. Decimal numbers is actually 0 to 9, but hexadecimal is 0 to 15, where there is no 10. Instead of 10 it is A, instead of 11 it is B, C, D, E, F. So actually there are 16 numbers. 0 to 9 becomes 10. Sorry, this is 10, this is 11, so this is 12, 13, 14, 15. So F represents equivalent decimal 15. So E represents equivalent decimal 14. So something like this. So they have been using hexadecimal format to represent your IP version 6. So IP version 6 is 128-bit address. So it's a very big number, which means it supports 2 to the power of 128 addresses. It goes around 3.4 into 10 to the power of 38 addresses. So almost a very big number and very large address space. Each and every human can get an IP address. And even if the internet grows more than double every year, for the next 50 years, we can still survive without any shortage of IPv6 addresses. Okay. So this is 128 bits, and now these 128 bits are written in hexadecimal format. So there is a hexadecimal format number you can see here. Here I wrote some number here. So in the form of 8 portions. So this hexadecimal 128-bit address written in 8 portions. You can see this is the first portion, second, third, fourth, 5, 6, 7, 8. So total there are 8 portions, represented as 4 numbers. We can say as group of 4 numbers can be one portion. Like I can take an example 3FFFE, and each and every portion is separated by colon, double dot. Each and every portion is separated by colon. So the next number will be 085B. Again, the next portion will be 1F, something like this. It will go on. Like that, we have 8 portions, and each and every portion is separated by double dot, or we just call it as colon. Okay. And now, and each portion is going to represent equivalent 16 binary digits. So binary number 16 binary digits, which means if I take an example of 3FFE in the first portion, now each number is going to represent 4 bits. So which means there are 4 numbers, 4, 4, 4. So totally becomes 16 bits, and each number represents 4 bits. Now the equivalent binary for this is, if you want to convert this 3 into equivalent binary number, you have to use 8421. So 3 represents 2 plus 1, and this is 0, 0. Similarly, if you don't write binary value of F represents 15. If you just see the conversion, F represents 15. So 15 means 8 plus 4 plus 12, 12 plus 2 14, 14 plus 1 15. So nothing but all ones. So anyway, you really don't need to write them in binary, but you need to have a basic understanding on how it is used, because in our IPv4 we generally use binary conversions for some advanced calculations, but here not really required, but good to know. So like that, each portion represents 4 bits, each portion represents 16 bits, and each number represents 4 bits, and each and every portion is separated by double dot. Okay, now the next thing, okay, so understand that IPv6 address is a 128-bit address and written in 8 portions, and each portion is representing 16 bits. So 16 into 8, it becomes 128-bit address. Now the next thing we need to understand is, okay, so let me just write down one simple address. I'll write one example address. Let me take an example. I'm writing 2001 0db8, and then 10000 0000 3c4d, and then 0000 0000 1 2 3 4. So I'm just writing one simple sample address for understanding how it looks. Now in this, the first part, we need to understand that just now we discussed each portion representing 16 bits. Like that, we got 1 2 3 4 5 6 7 8 portions, and each portion is separated by a double dot, that is colon. Fine. Now the next thing is understanding network and host portion. So if you remember, in our IPv4 we have something called network portion and host portion. Here also we have, but the names are totally different. So here, out of this 128-bit, the first 64 bits, first 64 means I can say 4 portions. So the first 64 bits, we call them as global prefix value. So the global prefix value is similar to your network portion. So we don't say exactly, it's similar. So there is no network host here, but instead the names are slightly changed. We call them as prefix value. It's the same thing. In IPv4, we also say prefix or slash value. So similarly here also, we call it as a global prefix value. And the remaining 64 bits, whatever the remaining half part, is generally referred as interface ID, which is similar to your host portion. But I'm not saying it is exactly 64. It can be anything, just like in subnetting. Generally in IP version 4, if you remember in IP version 4, the default subnet mask for any C class address is /24, which means the subnet mask is 255.255.255.0. That's what we say. But it's not default. It's a default, but it's not compulsory that you have to use the same subnet mask. You can use it as /27, /28, /30 as per your requirement. The same thing applies here also. So if you want, you can even make the first 5 bits as your prefix value, but for that you have to use /80. So by default, slash value is 64 in IPv6. This is the default slash value. We can say nothing but the first 64 bits are your prefix value. But if you want, you can change it to /60, /80. /80 means 5 portions. /96, /128, depending upon the requirement. So, but not compulsory. Okay, so as of now we are just following the default slash value of 64, which is the standard, just like default value. So the next thing, okay, now we need to understand, the next thing we need to understand is how we can make it a little bit, it looks very lengthy, but still we can minimize it as per the requirement. Like I can write 2001 as it is 2001. So I'm going to show you the short way of writing your IPv6. So whenever you have a 0 here, 0 means you can ignore the 0, you can write as 0 db8. So instead of writing 0 db8, you can write as db8 only. Now why exactly I'm writing here? So if I take an example, it is something like there is a number with 0012. So if I say 0012, nothing but it is 12 only, right? So if I write 12 or 0012, both are same. There's no difference because you can ignore the zeros before. The same thing applies here also. But don't think that you can ignore zeros everywhere. You cannot write this as 21 because 2001 is different, 21 is different. So the zeros before zeros you can ignore, but not the last zeros. So 2001 you have to write as it is, but you can just write 0 db8 or you can write db8, both are same, so both are correct. And the next thing, if you have all zero portions like 0 0 0 0, so instead of writing all zeros you can write as single zero, which means both are correct because all zeros, whatever the number of zeros you add, it becomes 0 only. So if you have all zero portions, you can write as single zero. And then remaining like 3C4D, I cannot do anything, so I have to write exactly the same. And but here I can write all zeros as one single zero. Similar way, I can write all zeros as one single zero. And then finally 1 2 3 4, no more changes I can do, so I need to stick to the same address. So now both are correct, so the address here, this is correct as well as this is correct. So these are just conversions, the other way of writing your addresses. So apart from that, there are some one more thing, like let me write down this again. 2001, I'm writing db8. So whenever you have a continuous zero portions means, so here you can see there is one zero portion and there's two zero portions here, continuous zero portions. So whenever you have a continuous zero portions, you can write them as double colon. So double colon represents continuous zero portions. Now, what is exactly that? Means let's take an example, you have one zero portion, or you may have two zero portions, or you may have three zero portions, or it can be four zero portions, till seven zero portions. You can just take 7 1 2 3 4 5 6 7. If you have all zero portions, anyway that's not a valid number, so maybe you have one, so you can just write as double colon 1. So this double colon represents 7 0 portions. So when I'm writing double colon 1, nothing but it's a total, there are 8 portions, one portion represents 1, and there are 7 0 portions. So it can be 2 portions, it can be 3, whatever the number, you have to use only double colon. So it's not correct like you there are 3 0 portions, I have write 3 colons, that's not correct. So don't think like that. If you have 4 0 portions, you have to write 4 colons, so that's wrong. So whatever the number of 0 portions you have, if they are continuous, it can be 2, it can be 3, it can be 4, whatever this, so you have to write double colons. So same way, so I'm just writing this 0 0 as double colons, so 3C4D remains the same. And then now again, as per the rule which we discussed just now, continuous 0 portions I can write as double colons, so I'm writing as double colon, and then 1 2 3 4. So I'm writing 1 2 3 4 as it is, exactly the same. So now I'll say this implementation is not correct, it is wrong. But now you can ask me why it is wrong. Just now I discussed that uh, instead of having continuous 0 portions, I can write as double colon. Instead of continuous 0 portions, I can write as double colon. Just now we discussed that, but now this implementation or this solution is wrong because double colon is not allowed in more than one place in the same IP address. So it's not allowed more than one place. Okay, it is allowed only on one place. So either you had used double colon this way, here or here. but it is not allowed to use the double colon or both at the same time. Means you cannot have double colon at the same time, which means the correct way of writing this address is, let me take 2001. If I take 2001 here, so 2001 remains the same, exact same, no change. And then DB8 also remains the same, no change. So I had to use double colon in any one place, either here or here. It's up to you. So there's no compulsory rule that you have to use only in the first or in the last. And 3C4D I'll write as it is. And then I will use normal 0 here, and then 1, 2, 3, 4. Okay. So this is the correct way of writing the address. So why? Because now it is very clear, because when you are writing double colon in more than one place, there may be a confusion here. So let me tell you what is the confusion here. So in general, when you try to write this address in any device, the device will not accept. Why? Because it will take this as one portion, second portion, third portion, fourth portion. So now here I can see 4 portions. What about the remaining 4 portions? The remaining 4 portions are in the form of zeros here and here. But now the device can assume, it can think there are 3 0 portions here and there is 1 0 portion here. Or the device can assume there are 2 0 portions here and 2 0 portions here. Or the device can assume that there are 1 0 portion here and 3 0 portions here. So now it becomes very difficult for the device to analyze which option is correct. So that's the reason you cannot use double colon in more than one place. Even if you try to assign this address, the device will not accept. Okay, so this is a short way of writing the addresses. This is one thing we need to understand. So what we can do is we can write continuous 0 portions, we can write as single 0. Means if you have all zeros, you can write as single 0. You can ignore the 0 before, but you cannot ignore here. Okay, and then if you have continuous 0 portions, you can write as double colon, only double colon, but this double colon is not allowed in more than one place in the same IPv6 address. So whenever you are into this type of situation, you can use double colon only in one place, either here or here. In the other place, you have to write exactly the same address. So now it is very clear. Now you can see if I write this address, now the device will automatically easily understand that there is one portion here, 2 portions, 3 portion, 4 portion, 5 portion and 6 portions, and the remaining 2 portions are in the form of 0. So it will understand that it is 0 colon 0 is present here in this. Okay. So now we have seen why exactly we need an IP version 6, and then we have seen some basic advantages of IPv6, and then just now we have seen how exactly it is going to look. And finally we need to see the classification of addresses. So now, just like we have ABC classes, now we are going to see what is the classification. Okay, so probably this classification of addresses we'll see in the next video, where we'll in detail see what are the classification of addresses, and then also we'll see some basic implementation of addresses, some basic things. Okay.